still music? That's weird. How do I turn the music off? That's so funny. That was new. Well, good morning and welcome to the CADclass podcast. I'm Josh. Yeah.
I'm Jake.
I'm Toby. Hello.
I still, after all these years, we still don't really have a good intro, and we still kind of don't know what we're doing. I still enjoy that. Oh my god. Anyway, good morning to everyone in our CAD community. This is going to be a totally special episode. As you can see, we have got a guest with us. This is actually someone that we have kind of this weird social media pseudo relationship because we've worked through and worked with him for so long, and we finally have him on the pod. So for everyone in the CADclass community, I'd like to welcome TooTallToby. This is the gentleman who has started the CAD example empire and has helped God knows how many people actually make a fundamental and foundational skill set across, good God, what is it, dozens of different CAD programs now? And has brought with him, I'm sure, some of the people from his TooTallToby community. So good morning to everyone in the chat. Josh, if you want to go down and say hi to everyone. Or not. Good morning, printed by John.
Thanks for that nice intro.
Yeah. Josh, can you even hear us?
I can hear you, but I've got an echo. I've got an echo.
Oh, okay.
Nice.
And
so
I
Josh
don't
is still going to be working on that.
And I don't actually have a second video set up. So 1 second.
All right.
Pardon
I'll keep going on.
me.
Well, good morning, printed by John, coming in early as always. Also came over to the podcast on TooTallToby's page on Monday. So thank you very much for being here. Grandpa Makes, CADtoby, I think he's coming from your side of the pond. PC Van Vliet, Vic Chung, good morning to everyone. Normally on these podcasts, we kind of get started by showing off some creations in our Discord community, showing off what looks good, what looks bad. That's not true. No one ever posts any bad things except for us. But we usually show off everyone's pages. But today we kind of want to get started in showcasing the relationship between CADclass and your page, showing what you've given to us and what everyone on our side of the community can actually get out of your side. And then just kind of chat generally, because we kind of want to know where you came from, what you do, and a lot of the things that people in the CAD community have seen, especially in like different subreddits, different YouTube pages, and they're kind of going, oh, it's that guy. Oh, fantastic, sweet. So all of the examples that we have done on this podcast for years, me speedrunning and being slightly out of breath, which is a little bit embarrassing, have all been made by this chap here. So Toby, thanks so much for coming on the pod.
Man, what a nice intro. That's really you're leaving me speechless, bro. Thank you. It's so kind. And I'm so glad to hear that it's been helpful. And it's been a lot of fun watching you and Josh and, obviously, especially you working through these challenges. You've seen me sometimes in your chat. A lot of times I'm just lurking or watching the replays, but it's a lot of fun to watch other people work through these challenges. It's one of the more fulfilling things that I get to see is getting to watch other people work through these challenges. And especially when they do things that I know are inspired by things that we've discussed on the channel or in the tutorials or in the tips and tricks videos. It's always awesome to see the different users kind of working through these challenges.
Dude, the amount of I think you're selling yourself short on the amount of uplifting that people get from all of your projects. Like genuinely taking people, or do you if anyone has spent any time on any of the subreddits about any of the CAD programs, they will just see litanies of people just going, hey, how do I make this? How do I make this? How do I make this? Yeah. And that's like 90% of what people post. Yeah. And the idea of actually people coming into this and going through all of your challenges and going, I don't need to make this big, gigantic project that's really complicated and busy. I just need to make a single part for myself, whether I'm going to be 3D printing it, laser printing it, sending it off to a client or anything like that. People actually seeing all of this thing or being able to make all of these parts and actually spreading out and using new tools and using all of these different parts of the software, which they've never really climbed into. purely because of all of your projects has genuinely elevated people from doing to, oh, okay, I can now grow off of my skill set.
That's awesome, man. Well, thanks for saying that. And, for those of you who aren't familiar yet, we're going to show the site in just a couple of minutes, but basically it's like a gym for people who want to practice CAD.
I dig that.
It's, you've got, you go to a gym, you've got all these different machines where you can work out different muscles. Well, in the CAD world at your job, you might only ever do sheet metal and you might never get into sweeping and lofting. And so we've created a platform where people can go and practice some of those other skills, working with the shell command, using delete face, using the slot tool, using holes, using counterbores and learning how to really leverage the hole tool. And that's like really what we've tried to create here is a place where people can go that takes them outside of what you normally do. Because a lot of times, in CAD and engineering, you do kind of get a little bit pigeonholed into just doing the same types of geometry because that's what you have machines for in the shop, or that's what your vendors are looking for, whatever the reason is. A lot of times you end up with kind of like a limited set of skills. And yet these 3D CAD packages, Fusion and Onshape and SolidWorks, they have so much to offer, and what I've always found, because I spent in my career a little bit earlier in my career, I spent a lot of time teaching. What I've always found is that when you learn something about one area of the software, you can often apply it in your niche area. And so it really is, not just working out for the sake of working out, but working out for the sake of learning that new tool that you realize like, oh, I could do this in sheet metal, it's in surfacing or it's in sweeping and lofting, but I could actually use this in sheet metal and help manufacture my parts a little bit faster.
What I find, what you're just saying at the beginning, really rung true to me, where you're like, being able to physically are forced to push you into other parts of the software is genuinely something that I have trouble with. Obviously Josh and I
which is funny by the way
skill set
because when you dive into something you get to know it. I would say you're a world-class learner. We've talked about this before in the pod, but there is still that barrier even for us at this high level where we go, oh, it's another there's like a black, right? There's a black hole here. How deep do I want to go?
and it's like CAD for me, especially like 3D physical solid modeling, it really does feel like when the only tool you have is a hammer, the only problem you see is a nail, where I'm like, I will do every single trick and manipulation I can possibly think of to avoid using T-splines and surface modeling, because it's like, oh my God, I need to learn that whole part of the software. No, I am now the R2D. The R2D2 is literally here for a reason. But I am now in the stage where I'm getting some of these parts manufactured from sheet metal companies, and I have quite literally having to rebuild quite large parts of this that has taken me years to make. Like now, I'm literally modeling at 3 a.m. today, purely so that I can get some parts manufactured. And it's like, oh my God, I need to learn the sheet metal workspace really significantly more in depth. So there is this like external force that's kind of pushing me into different parts of software that's kind of forcing me to learn it, even though I don't want to. So yeah, dude, all of your examples, everything that's like, oh, you need to make this in sheet metal. It's like, okay, all right. It's like homework. I know it's basically vegetables. It's like, okay, I need to eat it. I get it. All right, fine, fair enough.
Well, I mean, the nice thing is that in this environment, you're able to kind of ease into it because you're able to watch other people, and I think that's really the other part of it. I think you guys have done an awesome job of exemplifying this idea of community and having the community around to kind of help you through the process. And that's what we're trying to do on the platform as well, is to help give people a place not only to do the work themselves, but also to showcase their work to help other people. So for example, in all of the CAD challenges, there's a space where people can post their own tutorials. They can record themselves and then they can upload that, and it indicates what CAD system they're using. Because we have people coming in from FreeCAD, from Onshape, from Fusion, from all different CAD systems, a Libre. And so it's nice to be able to see somebody do a tutorial in a different CAD system, but it's even more nice to see them do it in your CAD system. And so, being able to, if you get stuck on a sheet metal challenge, for example, you could certainly go through and try to work through it yourself. And, like you're saying, try to like learn as much as you can. But a lot of times when you do that challenge and then you see an experienced user go through and do it, you're like, oh, you can do multiple edge flanges in one command. Oh, I didn't know you could do that. Oh, you can break the corners. You could break the corners like just by picking the faces. That's pretty cool. I didn't know you could do that. You start to realize these more like under the covers functionalities, more hidden functionality. And that's always nice too, a nice way to learn.
Yeah, I love that. I love that. I mean, the community side, that's one of the things when we first met that we talked a lot about was, and I know from experience, if you're sitting alone at home and trying to learn these things, like online learning is amazing, but it has these very real limitations where you go, A, I don't know what I don't know. And it's very hard to bump into getting to know it, right? And B, if I get stuck, I don't have an outlet. I don't have an obvious way that I can go about trying to figure out what's next for me. So I love that idea. And I mean, I think you're doing a great job with that community shared content as well. I don't think we've done a great job in that. We haven't done any job in that area really. But we've
you guys have that. You guys have the whole, Discord, and that way, as people get stuck, like I know there's people in there that are posting little short videos. Like if you get stuck on this, on this challenge, then here's a quick video showing you how to do it. So you definitely have a good community too.
Yeah, cool. So what I think I missed sorry for missing the beginning of this. That's hilarious. It was I had an echo, and there was, you get an echo. Sometimes you have the YouTube window open right alongside. So I was like, oh, okay, no problem. I'll just find where it's open, right? Wasn't open. Couldn't find it. Had to restart my computer, like classic, right? So, so Toby, I had the problem. You had the problem before the podcast. You were apologizing for that. And here I am, live podcasting, and it's like, what's going on? I can't find the problem. So anyway, sorry about that. But
good, man.
Forgive me because I'm hopping in after the intro. But I think it'd be really.
You missed a good intro.
I'll have to rewatch it. I heard you say that, and then my computer reset and it was over. But I would love to get into your platform a little bit more here early in the pod, and actually have you make a model live and talk through kind of how you're making it, both as a way to showcase your skills, but also to show off some of the platform, because I do think it's pretty awesome for everybody in our community.
All right.
And then after that, I want to get into your origins of CAD.
Yes. So we'll make some stuff and then we'll work backwards through why the heck TooTallToby evolved.
Yeah, that sounds good. Sounds like a good agenda.
Good.
Yeah. So I mean, the platform is at TooTallToby.com, and you can see here, this is what the homepage looks like. And basically what we've got here is there's a section up here in the upper left where you can go into play and learn, and you can access the practice models. It's also right here, right at the center of the main page, practice models. And with a free account on TooTallToby.com, you're able to get in here and you're able to start doing some modeling. Now, some of this library is limited to, it is a subscription plan. You can get a subscription plan. I know that's like the S word. You're not supposed to say the S word, the subscription word, but it is a subscription plan to access to the entire library. But there are quite a few models on here that are free for everyone. And each one of these items that's in this library is a 2D drawing that you're challenged to turn into a 3D model. So for example, this first one here, this is 240101. It was the first one that we released last year when we built the platform. So this 240101 is completed. It means I've already gone through and gotten the correct answer. And you can see here that it's a 2D drawing, and that 3,183 people have done at least one model. And of those, 2,704 people have completed this model. So it's got a pretty nice completion ratio here. You'll see that as you scroll down, there's some information down here at the bottom. So there's some community videos. So you can watch a video of somebody solving this down below here in this tutorial, kind of going through and explaining how they solved it using some different CAD systems like we talked about earlier. And just added last night, we've added the official TooTallToby speed modeling leaderboard. So with the TooTallToby speed modeling leaderboard, people can run this thing as fast as they can. So this guy here, number one on the leaderboard, TooTallToby, did this model in 46 seconds. Wow. Using Onshape. And PC Arduino here, Chris Odom, did it in just 50 seconds. So hot on my heels. And then this guy here, Jerry Smith, did it in 55 seconds. So we just added this last night, the ability to do this. Now, we also have a top 100 here. So all of the people's times who are submitting times here land on this top 100. We do have a little bit of a buffer in the beginning of this to make sure that people have the ability to do the challenges in offline mode. But you can see here that there's a lot of different people from all over the world using all different CAD systems, trying to complete these challenges. And you can see here that Jerry Smith ended up in 52nd with that time of 44 seconds. So some pretty fierce competition here. And then we love
seeing all the different countries that people
it's pretty fun.
That's fantastic.
And then we see here that we also have the data and analytics. This was also added in the update last night. And so if you are a user who's on the subscription, you're going to get access to this, and you're actually going to be able to do the runs once and then do the run again. So you'll be able to go through here and you'll be able to take this challenge again. So you can click try again here. So let's say we say reveal drawing. So here's this drawing, not too complicated. The drawings are organized by a level of complexity. So you can see that down here, the complexity is tier 1. You can see that the material density is listed here in the title block. And you can see that you are challenged to take that drawing and turn it into a 3D CAD model and then answer this question down here. What is the mass of this model?
So you have a question coming in the chat from Additive Adam. By the way, shout out Additive Adam. I'm pretty sure Jake,
that's a great
Additive
name.
Adam is the guy that we met at Open Sauce who was making the Hue Forge, the full color
no
Hue
way.
Forge. I'm pretty sure that's
sweet.
So welcome,
Well,
Additive Adam.
if that is,
do you want to answer this question here? Why no Tinkercad examples? I think I know the answer, but
yeah, absolutely. I mean, the platform is truly agnostic. So it's the examples, the challenges they're not specific for any CAD system. And I'm sure that we have Tinkercad users in here. In fact, let me answer this one real quick. So I'm going to put in the answer here, 73. Oh, no, that's incorrect. You can see this is incorrect, not the correct answer. You might have noticed from a little spoiler there, I did have the correct answer in there. So if I answer it correctly, then you're going to see here that it's going to let me specify, what my time was and what CAD system I used for that run. So let's go in here and say Tinkercad. So we'll go in here. Why no Tinkercad?
I think I know. I think I know.
He's right.
No, but I think I know the answer.
Oh no, this is something we definitely got to get in here. We got TurboCAD in here. We got to have
Well, no,
Tinkercad.
but can you actually apply materials and get the weight in Tinkercad? I don't think you can.
Well, you know what? Even if you can't, you could still, as long as you can get the volume. We've had users who have done the volume and then just brought up calculator and run calculator to prove that they're getting the correct mass.
Do you know what else I'm thinking, Josh? After speaking with some of the Tinkercad engineers, the fillets that you get on the parts are not actual mathematical fillets. They are polygon representations of it.
It's a trick. Yes, it's a visual trick.
So it's not. So it's technically not a fillet. It's just a part of a polygon for just like browser efficiency purposes. So I would bet if you try to make it on Tinkercad and there's a bunch of holes, like we did a bunch of counterboards in the example the other day, and fillets everywhere, I think that would probably mess you up a little bit.
I think you are correct. And so for all of those reasons, it would be still neat to see people doing it in Tinkercad. We have a guy that comes to our pod. I don't see him in here today, but he makes these Tinkercad models and he is a wizard. It's like
blows us away.
He's the fastest by far.
I think we definitely got to get Tinkercad in here, get Tinkercad users in here. I mean, for this one, I'll just say that I did this one in Fusion and I'll submit this answer. But the thing is that on these challenges, there is a tolerance on each of these challenges. So we'll see here that when we reveal the drawing, there is a tolerance. And this tolerance is something that I try to take into account the way different platforms solve different types of features. Now, a fillet being solved as a polygon, may or may not fall within that tolerance. But there are certainly scenarios where one software will solve a loft slightly differently or will solve a sweep slightly differently. There's even settings you can sometimes get into, like if you're in a sweep command in certain CAD systems and you say merge tangent faces, then it doesn't actually do analytic geometry. It'll do spline geometry to merge those tangent faces. So the geometry does change slightly. So there's a lot going on behind the scenes to try to make sure that those tolerances are kind of dialed in and are going to, allow users from different CAD systems to get valid answers.
I dig it.
We do feature a community scoreboard here where every time a user answers, they get a point on this community scoreboard. So you can see currently we have 157 challenges in the library. And again, kind of to Jake's point from earlier, there's all these different users from all over the world using all different CAD systems.
So beautiful.
Plasticity users. Let's go plasticity.
Wow.
So that's so rad. Oh my gosh.
We definitely got to get the Tinkercad
showing up.
And then part of
that's so awesome.
Part of that new update that just occurred last night was that now when I do that challenge and then I do the challenge again, whether I use the same CAD system or a different CAD system, I can go in here to data and analytics, and then I can see how I'm improving. So with ArchiCAD, I did it in 1:47. With Fusion, I did it in 1:08. Clearly, Fusion is the superior platform based on that. I mean, it is a little skewed because after you do it once, you kind of like have a strategy, but it is pretty cool that you're able to see it. And then of course on this tab as well, for our speed runners out there, they're going to be able to put in their speed run videos. So the way this is structured right now is that you have to be a member of the subscription in order to do the speed run and submit it, but everybody can view the speed runs. So if you come in here, as soon as you come into a new challenge, like let's say I go into a new challenge that I haven't done before here, once I get into that new challenge that I haven't done before, I'm going to see that table of tutorials. I'm going to see that table of speed running. It just got posted last night, so they aren't going to be filled out yet, the speed runs. But just, that's basically the gist of this, is that if you get stuck on the challenge, if you don't finish the challenge, we want you to have resources. And we want you to have those resources in your CAD system, or at least be able to watch somebody go through and model it in another CAD system.
You know what I'm just realizing here live on the pod is that so we had already talked about, we have done some of your models live on our show in the past, and we had gotten some feedback from our audience that they love doing that and they want those challenges every week. But Jake and I that's not exactly what we focus on. So we had to search the tutorials and go, we're frantically going before the pod, what the heck are we going to make come up? And so it turns out that's pretty tough to do. But what I'm realizing would be really nice for our audience is maybe once a week, somewhere in the range of 10 to 10:15, if you could share one of your free models to say, hey, this is going to be the weekly challenge. You're going to work on this one, drive a little bit of traffic over to TooTallToby. That would be totally rad. I would love that. So maybe just put a little calendar reminder, post it on Discord. We'll amplify it to everybody.
Yeah.
And then
let's go.
If we're live, we'll try to shout it out on the pod. That'd be super cool. I would love that.
Go.
And we'll just have you be the person that's telling people what model they're going to make, and we don't have to think too much about it. So I think that's an easy win-win.
I mean, not only for your platform, but really anybody who finds himself in that situation. It could be that you're an instructor and you're looking for some models that have all the dimensions that you need, right? How many times have you run into that issue or talked to instructors about that issue where it's I took a print from a book and I printed it out for my students and I found out that a dimension was missing, so frustrating for the students, I'm sure, and also frustrating, but all these models,
all the way around.
That there's a way to solve these because you can see the completion ratio here. It shows you somebody solved it already, so the information you need is definitely there to solve it. And it's also good, if you're an engineering manager and you want to challenge your team to do something, there's definitely a lot of different people who run into that situation where they're just looking for challenges to share with their team. And,
we ran into that challenge. We shared some models that did not have all the dimensions, and our audience was like, "Well, I had to make some of this up," and that's not a very nice user experience. So apologies to the CADclass listeners. Hopefully that doesn't happen again because we've got an actual expert in the house. PC Van Vliet says this, and then maybe we'll dive in and get this tutorial started. But which would be better, faster or less steps?
Yeah, great question. So on a lot of these challenges, I post a video. I kind of have a special parking spot for my tutorials. And that parking spot is usually up here, Toby's tutorial video, where I go through and explain my workflow. And, longtime instructor, longtime user, I almost always favor more explicit features in the tree. So to answer that question, which would be better, faster or less steps, more explicit features in the tree is generally going to be better. Meaning, if you've got a cut extrude, in this example here, if you've got a cut extrude and you've got a boss extrude, this hole that's going through the center of this model here, don't feel like you need to extrude all that geometry all at the same time. You could do the boss extrude as one feature, and then you could do the cut extrude as a different feature. And the reason that's beneficial is because then you can name them differently in the tree. And then when you go back and you look at those features later on, you're going to be able to understand what the point was of that tree. When it comes to what we're doing here, the speed modeling, the speed modeling and the tournaments, the CAD versus CAD tournaments, which I know we haven't really talked about yet, but that's a lot of fun. And it's a fun exhibition to kind of see people really working off their skills and watch them feeling like they're under pressure. But you want to remember that the idea of this being
that's not how you modeled in real life.
You want to remember the idea of this whole platform is that it's kind of meant to be like a gym for learning some best practices and getting better at 3D CAD. And so that means just like when you go to the gym, you could do 50 reps of just the bar, but that's not, just because you're doing them really fast doesn't mean you're necessarily getting a better workout. It doesn't mean you're going to be better off in the long run. What we really want is we really want people to find that balance between learning efficient, time-saving shortcuts but not sacrificing good quality CAD work. You know, like you can still follow best practices and be fast. It's the point of this is not to just like hack something together that nobody's going to want to work with. The point is to help you understand, like, oh, whenever I exit a feature, the feature remains highlighted in the tree. That means if I'm going to, you know, Boolean copy that feature, I don't have to select it again. That's a good workflow for me to remember. I do that all the time. So like knowing that is pre-selected as soon as I finish the feature, that's good to know. You know, like little things like that, little workflow. Oh, when you right click, this is the menu that comes up. Like that's good to know. You know, all those little things are what we really want people to learn. And a lot of times it's better to learn those in like this type of a fun environment than to learn it when the machinist is standing over you. Like, we need to get this out the door today. Like if we don't start cutting steel in the next 5 minutes, the machines are going to sit all weekend and no one's going to be happy.
Well, it's a heck of a skill. And I mean, even when you go into an interview, a lot of the CAD interviews are going to you're going to have some sort of CAD challenge. They're going to ask you to do something and they're going to want you to be able to talk through what it is that you've just done.
Right.
So you don't need to go to school to do this stuff, but you do need to spend a lot of time, and like to your analogy point here, in the gym. You have to practice these things.
Yeah.
And you have to be
I don't
ready.
think I've ever told this story. I got a story that I don't think I've ever told.
Let's hear it.
When I was interviewing for a CAD engineer position, they said, okay, yeah, your resume looks good. We just want to have you guys run through a CAD model, you know, do it as fast as you can, and we'll, you know, I'll check on you in a little bit. I was like, yeah, sure. And they hadn't told me what their company's CAD software that they use. And I was like, oh, which program is going to be? And they go, oh, Inventor. I'm like, okay, yeah, I'm really proficient with Fusion. You know, same family. It should be pretty easy. You know, it's just like a little weird merging of like SolidWorks and Fusion. Like it's you can understand it, you can get it. And I'm like, okay. So I like sat down, they gave me the file, and they opened up Inventor, and it was the version from like 2002. And I was like,
wow.
I'm like, what? And then they said, oh, here's like a problem example. And I'm like trying to make it. And then I look down and this computer is like ancient, like ancient. It's that like ugly yellowed white case from the 90s computer, like a Dell. And I was like trying to make this. Yeah. Like I was trying to make it as fast as how I design while trying to learn this new program in an interview. And I was like, oh my God. Like this is insane how slow everything is, and just how much I kept on tripping myself up because it would have to load for a couple seconds when I applied a horizontal constraint. Like it was absolutely ridiculous. So like
spoiler alert, he got the job and it was terrible, as you could imagine.
Did they explain? Were they like, we were just trolling you, or like we were just trying to figure out if you could do it?
No,
like did they explain,
no.
or it was like it was all legit?
I looked around as I'm doing this, and everyone else's computers were like this. And I looked around, I'm like, oh, everyone here is like over 60. I'm like, I didn't even realize that when I walked in the door. And they were like, they still had all those gigantic like A5 printouts.
Nice.
And I was like, whoa. Like I wasn't expecting it.
Yeah. Alrighty, Toby. Let's dive into a model. Yes. I would love this. Right. This is the bit that I'm like, you know, put my hands together. I want to hear it. I want to see it. I'd love to see it live. So,
and I want you to talk your way through it as well.
So one of the things that's kind of cool about this platform is that we can sort by the level of complexity. So we mentioned the complexity earlier. It's not necessarily difficulty, you know, for Jake. Like something might be really difficult for me. Jake could probably just do it no problem, you know. So it's not difficulty, it's complexity. Right. So we've got tier 1, tier 2, tier 3. What do you guys think? What should we do for this tutorial?
Whatever, you know, not we don't have to go crazy here because I want to keep it. Let's keep it
tier
within
4. Okay.
Yeah.
I like how Jake's taking charge.
There we go.
All right. So we'll do a tier 4 model, and we could do one that, you know, that I've already completed, or we could do one, you know, that I haven't completed yit.
Up to
what
you.
Do you think?
Up to you.
I want to see that sheet metal one at the top right.
Okay.
Oh, because he's in the sheet metal mode.
Great choice.
I'm basically just using this to like fish advice.
This is good. I love it. All right, great. So here we go. So looks like we've completed this before. We did it before in 12 minutes, 16 seconds. So maybe we can see if we can improve our time. I think this one might be, this one is available for everyone as well. So great choice, Jake. So anybody out there who signs up for a free account can try this one, 240107. And I'm going to do this in Onshape, so you'll be able to look up my model as well.
All right.
So I'm going to click in here to try again. And then what I'm going to do is I'm just going to kind of move this over here so that you guys can see the clock here. maybe I'll
show that we're not cheating.
Yeah, make sure that I'm not cheating. Exactly. So
this isn't CGI, guys. This is real life.
This is real time. We're doing this in real time. All right. So
while you're doing all the modeling, we're also going to be quizzing you about CAD models and dates and size and dimensions.
Oh, I'm ready.
Different manufacturing things, interviewing you at the same time. It's like Hot Ones, but for CAD modeling.
Dude, I love it. This is what I'm all about. So, all right, let's do it. Here we go. I got the drawing up actually on my second screen. So I'm going to do reveal drawing, and here we go. Let's get this thing going here. So what we can see here from this drawing is that the drawing here is a sheet metal design. Now, even though the clock is running, a lot of times what I'll do is I'll start out by just kind of thinking through the challenge. And one of the first things I always ask myself is, where should the origin be located on this model? I think that's just like a general good practice when you're doing 3D CAD. Now, when it comes to sheet metal, you also want to think to yourself, where should the first feature be in the sheet metal design? What should that first feature look like? And I think that in the case of this model, my first feature is going to look something like this. It's going to be a line that comes over and a line that comes up like this. Now, that might not be that intuitive, but in a lot of CAD packages, if you can have your first sheet metal feature be 2 or more entities, you kind of set yourself up for everything else. You give yourself kind of a good anchor point, and you really set yourself up to do those future features. So I think what I'm going to do is I'm going to put the origin down here in this corner. And again, even though the clock is running, I just think it's really good practice to get into. Before you even start doing 3D CAD, think about this question. Where's the origin going to be, and why? So why is the origin going to be down there? Well, a lot of the dimensions seem to be coming from that lower corner. So that's certainly one of the things that I look for as a candidate as to why to put the origin somewhere. And in this view here, the origin is going to be right down the middle, because we have what's called center line symmetry. Now, what that means is I can save some time and also just make a better parametric model by only modeling half the model. So now I know what my first sketch is going to look like, and I also know what my first feature is going to look like. My first feature is going to be a sheet metal, thin feature or a sheet metal extrusion. It's going to have a 3 millimeter wall thickness. It's going to have a 5 millimeter bend radius, and we're going to bring this over. Now, the next question is, do we bring it all the way over to the max width, to this 116, or do we maybe bring it just to this width here? Well, this gets into kind of your knowledge of sheet metal. That's where you have to decide how far over you're going to bring this thing. Because if you really know and understand sheet metal, what you know is that when you go to make this edge flange here, you could have it come off flush to the existing face, or you could have it come off with this bend here. So my knowledge of sheet metal in this case is going to tell me that that first extrusion is only going to go out to 1/2 of 100 millimeters. So that kind of gives me a game plan for my first feature. Then I start thinking through like, okay, now what are my next features going to look like? So probably my next feature is going to be a second flange that looks something like this, like kind of comes over like this. My third feature is going to be a cut to lop off that corner, maybe a cut with those fillets. And then my fourth feature is going to be this tab down here on the bottom. And then after that, it's just a matter of adding a couple of fillets, a couple of holes, and then we're good to go.
So is there any reason why you aren't doing all of the flanges and folds first, just to kind of get the maximal sheet metal tool, and then doing the cuts and the drilled holes and the fillets? Because in my mind, those are two separate categories of CAD modeling.
Yeah, I mean, a lot of times that is the advice, right? You do your bosses, you do your cuts, and then you kind of save your fillets and holes for later in the order of the feature creation. And then if there's draft, you figure that in as well. And that certainly is valid. I think that, in the case of this flange here, because, different CAD systems give you the ability to edit this flange on the fly versus having to cut, model it square and then cut it off in a secondary step. It's going to depend on the CAD system as well. But I think that, because those two features are so obviously related, it just makes sense to, kind of make them close to one another in the tree. So yeah, generally this is the way to do it. Like, do your bosses first, then do your cuts, your fillets, your holes. But, there's always time to kind of deviate from that, that basic plan.
Yeah. All right.
Yep. All right, cool. So now that we're in here, we already burned off 4 minutes. Let's see if we can go a little bit faster now with the modeling. So I'm here in Onshape. I'm creating a public document. I'll call this one CADclass. I know you guys already have that CADclass keyword there. So 0107 SM angle bracket. So this way you guys can look this up if you want as you are searching the Onshape public space. That's the cool thing about the Onshape free Onshape account. You can search that public space. And then I'm going to start out here on the right plane. I'm going to use my S key. So I'm pressing the letter S on my keyboard to use this shortcut menu. The S key menu is something that is in several different CAD packages and really saves you a lot of time. And then I'm just going to press N to get normal 2, and then S key again, and I'm going to go into the line command. Now, something I really like about Onshape is that when I go to create this line here, the length of this line is supposed to be 30 millimeters. Well, because Onshape has you do the second single click here and then input the length of the line, you can have that line oversized but still connected to the origin, and it adheres to that relationship at the origin. This is an example of something that you might learn by trial and error, and something you could learn by going to the gym here on the website, and then you realize like, oh, that's pretty sweet. Yeah, you can, because in other CAD packages, what you'd have to do is you'd have to draw the line out this way first, then end the line command, then start the line command, and then draw the vertical line. The other thing that I see a lot in the speed modeling runs from the users in the community is they use this trick a lot. They do rectangle, and then they do the dimensions for the rectangle, so 30, 105 here, and then they take these two lines of the rectangle and make them for construction. So that's something that I see quite frequently in the TooTallToby community. They really like that move, and they use it in a lot of different spots. So definitely one that that I've seen them use a lot. You could definitely go either way, but I think that for me, what I would end up doing with this one is what I did initially. So line over to here, auto dimension to 30, line up this direction, auto dimension 105. And then we're going to jump into our sheet metal tools here in Onshape. Now, a lot of CAD packages also have the ability to search. So if you don't know where the tools are, you could search here and you could just start typing in sheet. Most of the CAD packages nowadays have some type of a search field like this. And of all the tips and tricks I give, that's one it's pretty universal and definitely can help you. So this is going to be a sheet metal model. It's going to use the Onshape sheet metal function of extrude. And then I'm going to pick the entities that are going to get extruded here. I'm going to say that I want this to go out to the depth that I described earlier, which is 100/2. If you can't do that math in your head, you can just type it in, which is pretty nice. And then you can type in 3 here for the wall thickness, and you can type in 5 here for the default bend radius. Now,
I much prefer Onshape's sheet metal functionality than Fusion's already.
I mean, in the tournament, the tournament last year, we had sheet metal models, and the winner of the tournament was a Fusion user. And when the sheet metal models came up, I was worried, and he just smoked them. So yeah, there's some good stuff to watch there. Shout out to Rambro's Workshop, who won that tournament. So then the final thing we have to remember is that in our initial plan, we said that we were going to use we were going to put the origin down in that lower corner. So you have to be aware of which direction the sheet metal is going on to. So the sheet metal wall thickness is going to go either to the inside or the outside. And that's something that you control whenever you're doing sheet metal, regardless of the CAD package. And in this case, we control it here, flip that side for the sheet metal. So it's going to be very important that you model that correctly. So now we're ready to move on to our next sheet metal feature, which is to pick this edge here and then launch what's called the flange command in Onshape. So we're going to be bringing a flange out here, and we're going to be bringing that out to that depth of 100 millimeters. So 100, enter. And then we're going to take a look at this thing looking down from the top. And this is where we can specify where that flange is originating. Now, we want it to originate from this point here because that's the point at 100 millimeters or 100/2. So we're going to say that we want that to use the flange option here for hold line. Basically, in any 3D CAD package, you have this menu here where you can control where the sheet metal flange is coming from. And in the case of Onshape, the option for hold line means that it originates from the original end. Now we're making this a distance of 100 millimeters here. And this is another example of kind of going to the gym. I'm going to hit the green check mark, and then I want to confirm that I'm getting a distance here of 100 from this face to this face. And in Onshape, that's very easy to confirm. All you need to do is click on the first face, click on the second face, and then look down here in the status bar type area, and it tells you what the distance is between those two selections. So that's another, good shortcut to look for and to learn about. And it also helped me understand that if I type in that depth in the flange command, I'm going to get the actual distance from the original face over, as opposed to like the inside of the material or the inside of the bend, something like that, that would be good to know for future applications. So now I'm going to pick this face here, begin a sketch. I'm going to create a line that comes down. I'm going to use the trick like Jake used the other day where I come back, hold my mouse over the endpoint, and then come over, and that lets me jump right into a fillet. Kind of nice there to get into a fillet right from that endpoint. I saw you use that, and I said, I got to learn how to use that too. So
it is so I mean, we talk about this all the time, but like those little tiny little tips and tricks that I can sling out and go, oh yeah, look at how much I know. I learned most of them from like YouTube videos of like Fusion 101, Fusion Basics, Learn Fusion in 2 minutes, all those kind of videos, because they are just peppered with golden nuggets.
Yeah, it's definitely one of those things where, you know, the more you watch other people do it, the more you have the opportunity to learn. I know that there's been plenty of times where I've watched presentations that have nothing to do with shortcuts, and then I see somebody do something, I'm like, oh, you can right click to do that? That's awesome. So this is something else I noticed you did in Fusion, and Onshape does this really well too. I'm going to jump into an extrude command, and I'm going to do a remove, and you can see here that Onshape is able to pick up on the boundary of the face. I didn't have to sketch those extra lines. So that's something that's always good to be on the lookout for. And this could just go maybe up to next just to cut through that one material side there. And there we go. This thing's really coming together. And so now I'm going to be creating another one of those flanges like I did earlier. So we'll jump into the flange command here. Once again, we're going to say that we want that distance to be 30 millimeters. 35 millimeters. We're going to say that we want that to use that hold line option, so it goes down to the bottom. And now you see Onshape is telling us that that's going to be a problem. And so what we're able to do here is in the Onshape flange command, we can say we want this to be a partial flange. So you can see here, we're able to just take this and drag this over and kind of figure out what that's supposed to be. And so it looks like the dimension that I'm getting in the book is 50. So this is going to be 100 minus 50. Again, still struggling with that math. So 100 minus 50, and then I hit the check mark. And then real quick, I just pick on this edge, look down here, and confirm down to the bottom. Yep, 50. That's what the drawing is calling out. That's what we want from that one. So now we just have a couple of final features to add here. We've got our fillets and our holes. So for the hole here, we could pick this face, begin a sketch, begin the circle command, single click on this edge here, give the circle a dimension. But another thing that I often see people do in Onshape is they start out with a line command actually from up here. So single click the line command, come down here, and then type in what the location of that hole is, and then jump into the circle command so they can just drop the circle right onto that endpoint. Pretty slick, right? So this is something when you're watching the people run through and do their speed modeling challenges, you start to realize like, whoa, I could be saving a lot of time here. So one of the things that I like to do a lot is in a lot of CAD packages, they give you the ability to do a diameter dimension when you're doing a revolve. But instead, what I'll do is I'll kind of hack that functionality and use that to help create a double dimension in this application where I'm doing a mirror. So this is a 12 millimeter diameter hole, and the distance from the front of the tab down to the location of this hole here is 25 millimeters. But then the distance across here is 70 millimeters. So instead of doing a diameter and getting that double dimension, I'm just doing it right there in the extrude or in the sketch command with that double dimension across the center line. And then the final thing here is just adding a couple of fillets. So we're going to be adding a fillet on this edge, and this edge. And that fillet dimension is going to be 7 millimeters. 7 millimeters in 6 places, 3, and then we're going to mirror across. So in Onshape, the default mirror is the body mirror. So all I have to do is pick this face here for the body, pick this face again for the mirror. Oops, pick this face for the body, pick this face again for the mirror. And that lets us mirror that. We're going to use this option for add so that it adds those two bodies together and merges them together into one single body. And then we do what we call the final spin. We just kind of like look at this thing and make sure that it looks like the drawing. We come down here to our materials and we say assign material. There is a TooTallToby custom material library that you can access. So if you're an Onshape user, we've also posted one for Fusion users. So this is going to be plain carbon steel. And then we finish up by going to measure the mass. We're coming up with a mass here, 585. So we come down here into our validation field, 585, enter. And oh yeah, whenever we get that purple box, that tells us that we did it correct.
Go.
And so we see here that our previous time was 12 minutes and 16 seconds. So we were just a little bit slower this time.
Yeah, with interruptions and chatting halfway. That's pretty impressive.
That's
awesome.
That's so awesome.
I have a quick question, which I just realized during this. Do you ever get people cheating and just drawing a hole that cuts the material because you can put the material weight in? I mean, this is a funny question. I was like,
we sure do.
Oh,
yeah, that's a great question. So one of the models that's in here that I noticed when we were deciding what model to get is called, let's see if we can bring up this model here. Let's go back to our library. Is this one here. So 240208. So let's take a look at this model here and we'll say reveal drawing. So when this model was being created in a tournament, it's a very similar model to this one. It's actually slightly different. But when it was being created in a tournament, one of the users realized, like, I could just put this slot anywhere. And because the top and the bottom faces are parallel to one another, we're removing the same amount of material. Now in the tournament, it was actually kind of funny because it was a series of counterbores. It was 4 counterbores. So I had 4 counterbores here that were spaced unevenly. So I thought like, oh, this will be fun. We'll trick up the users, you know, and they're gonna have to like add a linear dimension, add a linear dimension, add a linear dimension. And he came in and he just went bup, 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 dropped them anywhere, you know, and moved on. And so that user's name is Ivan. And that became known as the Ivan exploit. So we have a term in the community called the Ivan exploit. Great. And so a lot of times, like on these speed modeling runs, for example, there'll be a condition that'll say like no Ivan exploits. Like here in the top 100, when you finish a model and you expose that top 100, there'll be a condition at the top of the board that says no Ivan exploits. Like you're not supposed to, when you're running these times here, you're not supposed to be running them with the Ivan exploit. But yeah, users can certainly, you know, it's a cheat, but it's a cheat that we have accepted as part of the community, because when we do these challenges, we do them in terms of trying to help people to compete, you know, and watching the different people compete with one another. And so in order for there to be a non-human arbiter, I just take the input from like YouTube, for example, and the input is what is the mass. So however they come up with the mass, I accept it, you know. And so then it becomes kind of an arms race where I have to come up with different ways of preventing them from Ivan exploiting. So for example, in this model here, I might go through and change the drawing and add a curved surface on the bottom so that it's not 2 parallel faces, or like the angled face here. So now the location of those holes is very significant. You know, so there it becomes kind of like an arms race between me and the competitors.
That's great. That's
the thing is, when we get into the tournament and we get into the deeper stages of the tournaments, we're doing like tier 5, sometimes tier 6 challenges. So like you spend more time trying to get clever with an Ivan exploit than you would just doing the model correctly. Yeah. And so, you know, it doesn't come up as much, but you know, and then the other way of I don't want to call it cheating, but the other way of using this app that a lot of people do is that they don't care about their time at all. So they'll do like a reveal drawing, and then maybe they'll just do like a screen capture, and they'll go and they'll model it in their own time, and they don't care at all about the time. And then they'll come back in later and they'll start the challenge up again, and they're just using this as a validation field. So they'll type in their answer, you know, whatever this one is, 204. I think this one is, yeah. Oh yeah, I got it right. I remembered this one. So 204 is the answer. So they got it in 3 seconds. So what we do is when somebody comes in with a time that low, we just purge it from the results. So that's not going to show up here as the fastest time. You know, it's like a fastest reasonable time here that shows up in this list.
That's funny.
Yeah, we're not going to dethrone this guy. Look at Metab. He's a regular. And look, here's Rambros. This is the current world champion of 3D CAD speed modeling.
That's awesome.
That's right.
Is the by weight thing something you came up with? Is because I think that's a pretty interesting way to do it. And I was
that's what we do in universities.
Models.
That's what all my finals was. That's validation. Yeah,
there you go. Spoken like a non-engineer. We have one real engineer on the team and one fake one. So
yeah, I mean, definitely not something I came up with. It's definitely, you know, I've taken plenty of CAD exams using different CAD systems where they ask for the answer in weight to try to validate that you did it right. They've also asked for the answer in other ways, like center of mass. But if a lot of what I do is with the community, you know, you guys were with me on Monday, and a lot of what I do is with the YouTube community. And so with the YouTube community, if I'm asking them to enter an answer directly in the YouTube chat, I don't want them to have to enter in 3 different fields. Possibly some of them are negative fields. And the other problem is if we did center of mass as the requirement, we would have to tell them where the origin is. Yeah. And I feel like that kind of spoils it. Like, it's so fun to watch 2 different users live during the tournaments modeling and starting in 2 different locations on the model. Like it is so enjoyable because a lot of times they end up at the same spot at the same time, you know, even though they started at 2 totally different ends of the model. So yeah, so weight seemed like it would be a really good fit here, but that's definitely not one that I can take credit for coming up with. You know, and as Jake said, you know, we've taken plenty of exams where they ask for that.
Yeah, exactly. All right, so we've got time. We've got about 10 minutes left on the pod. Maybe a speed round of questions, and then some calls to action / final touch points for you two, TooTallToby, and that'll be about it. Jake, do you have any speed round questions?
Yes, I do.
Go.
How tall are you?
So good question. I'm tall enough that like I don't fit in some cars and hit my head on stuff.
Oh, okay, okay. So it's appropriate.
Yep. Yeah.
Is there a specific height that we can look at?
I mean, there is. A specific height, yes.
Because
Well
I'm
played.
6 foot and I drive in a little my car's a little Fiat 500.
Nice. Fiat, nice.
And I fit in there just fine. I
Yeah,
love that car
good.
so much.
I like it.
No, I kind of want to learn about your origins of CAD modeling and how it kind of brought you into it. Because what I find is most people either they have an end product in mind that they want to make, and so they start with the CAD modeling and then go into the hobby manufacturing to get to the end products, or they've already been making stuff for years, and then it's like, okay, now I need to get serious. I need to learn CAD to make this project or to just kind of push my skill set. So I want to know where you started out.
Yeah, so for me, started in manufacturing, came out of trade school, got a job in manufacturing, was doing sheet metal manufacturing, progressive die design, moved into some fixturing design, did some plastic injection mold design, and then went to work for a reseller, a CAD reseller in Pennsylvania, and did tech support and training for SolidWorks. And that's really where I learned a lot of my skills doing CAD tech support and doing training. So taking inbound calls from customers who were stuck with both modeling questions and with just like general computer management issues with the software not running, etc. And
that's hard work.
It's enjoyable. It's actually like my favorite thing to do. So
the people that I used to call on SolidWorks, they were creative as hell. They were like, oh yeah, for this whole thing, you should actually design it as a really thick sheet metal. Then you can do this and that. And I'm like, oh my God, that's genius.
Well, and that's where doing the training was so valuable, because once you start doing training as well as when you're teaching classes and getting questions from students, and especially teaching classes across the spectrum, you start to learn those types of creative workarounds where you're like, exactly what you said, you could do it as sheet metal, even though you're actually trying to create some type of textile application, or, there's so many different ways of using the software that you learn about when you get into, weldments. Like the weldments training classes are really all about multi-body. And then you realize like surfacing is also really all about multi-body, and you see how all these different things come together and how you can kind of like springboard off of the different ideas. So that was a very enjoyable time in my life. I got to say that, it was definitely one of the best jobs of my life, and I knew it at the time. And so like, that makes me feel so lucky. Like, it's like, I felt so lucky all throughout that period in my life. And I knew while it was happening that like we were in a very special moment in time, and like, and all good things come to an end, and that's just how life is. But like, it was really, really a cool moment. I really enjoyed it. And I just was like sucking up information all the time. And so in working that profession, we would often get people who would call up for tech support, and they would say, hey, what's the best CAD system out there? What is the best CAD system? And I would always say, it's not so much about the wizard, it's not so much about the wand, it's more about the wizard. And what I would say is, like, if there's a Creo user, a Pro Engineer user, and they're going up against a SolidWorks user or like Mechanical Desktop, you guys remember Mechanical Desktop? So the precursor to Inventor, it didn't really matter like the CAD system they were using. What mattered is that they really understood the tool that they were using. They were truly a wizard. And so then I started thinking like, oh, I would love to start seeing some wizard battles in this arena, And so that's where like the genesis of the CAD versus CAD tournament idea came from.
Ooh, tell me more. Tell
really
me more about the CAD v CAD tournaments.
So the CAD versus CAD tournaments are something that, we've been doing for quite a few years now. We're very excited about them. And we actually have another one that just got announced today. So this is really perfect timing. But if we look here on the webpage, you can see you can go back to the 2024 Spring Open tournament. So the Spring Open tournament from last year, you can kind of see what the brackets look like, what some of the matchups look like. So Onshape versus SolidWorks, SolidWorks versus SolidWorks, Inventor versus SolidWorks in one of the brackets, Libre versus Onshape, Fusion versus SolidWorks. So we had 16 people from around the world in this tournament competing, and they go in an elimination style tournament until we go through the round of 16, the round of 8, the final 4, and then we get into the finals. And so it was none other than our good friend Airwick, who was an Onshape user, who won this tournament. This was the Spring Open tournament right around this time last year. And then After that, we did the World Championship, the 2024 World Championship. And here you can see what the qualifiers looked like. And the cool thing about this board still being up is that you can see that the way that people qualified for this tournament and the way they got seeded in the tournament was they submitted a video of them speed running. They submitted a video of them speed running.
I was like, this is a funny video.
Yeah, this isn't them speed running.
It doesn't look like speed running to me.
So you can see here that what he's doing is he's trying to create 3 models in a row as quickly as possible. So this is Fusion. This is your guys' gig. And this guy is an absolute, this is real time. This is not sped up. This is how fast he was going through. Yeah. And absolutely just smashing through these 3 models. And so this is what we're going to do. Yeah.
Legend. Whoa.
Yeah. So obviously this isn't the first try or anything. Like you can try it over and over and over again. You can memorize the dimensions, but you have to make it perfect. No Ivan exploits. No Ivan exploits on this one. So you have to make it perfect.
Oh my god.
Yeah.
How is he going this fast? This is incredible.
Yeah.
He's got wicked keyboard shortcuts going on.
Wow.
So you model the first one, you click, it's just like a speed run in a video game. You click your waypoint. And then you model your second model. You have to show on screen, you have to show that you got the correct mass. So that's one of the rules of this video. You don't enter it anywhere. There's no validation field. You just have to show it on screen, and it just has to be clear. It can't be like super teeny tiny that, you know, that I can't see it on the video. And then you submit your video to the leaderboard. I look at the video. This is a sheet metal one. I don't know if he's oh yeah, he's doing it sheet metal.
Wow.
God, that's crazy.
This is epic.
Yeah.
That's intense.
Yeah,
like one of the things that we hear all the time from people coming to us, and they go, "Hey, so I see you guys have, you know, got a lot of stuff on Fusion, but what is the best, you know, CAD program?" And it's like, as you said before, they're all incredibly powerful. It's like if you ask the exact same question to like coding guys, it's like, "Hey, I want to learn to code. What should I, you know, what program should I learn?" Damn near all of them will say it doesn't matter. They're all incredibly powerful. Just pick one and go. They're all going to have their nuances, but they're all basically, you know, the logic behind them are all pretty much identical. It's just kind of different styles. And so, like, even when I see, I mean, within the CAD community, there's a little bit of up-nosedness where they're like, you design on Fusion? Gross. That's for hobbyists. No,
I think it's sick. I mean,
I'm a SolidWorks guy. I actually do CAD modeling. It's like,
we got the world champion in the chat right now. He's actually he's calling out a little controversy with this run. He's saying he actually made custom scripts for this video.
Look at that.
That's something that is against the rules. So if I had caught that, I would have said like, "Sorry, Great Nate. Like we're gonna have to have you run it again." But you know, regardless of whether he made custom scripts, it's still super impressive how he's able to navigate the software. And so, you know, to your point, Jake, like what is the best software? Well, when we did the tournament in 2020, in 2022, we had we had an Inventor user win the whole thing. When we did it in 2023, we had a SolidWorks user win the whole thing. When we did it in 2020, I think I need to go back one more year. Yeah, regardless, over the past 4 years, we've had a world champion using Inventor. We've had a world champion using SolidWorks. We've had a world champion using Fusion 360. We've had a world champion using Onshape. So we've had world champions from many of the different CAD systems, and we're very much looking forward to seeing who the next champion is. Now, we're about to do, in May, our Spring Open tournament. So you're hearing it here first for the first time on YouTube, hear this? The first time live
Shout out to those in our audience. Sign up.
Yeah, so if you go here, if you go to tournaments and you go to 2025 Spring Open Tournament, you can get onto this brand new leaderboard. You can model these 3 models, record yourself modeling them. You can see here's a link to compete. So you can record yourself modeling these, and you can actually qualify for this upcoming tournament. There are prizes for these tournaments. So it's very exciting. It's a very exciting time. It's one of my favorite times of year when we get to the Spring Open. And I'm excited to see who competes in this one and who wins. And I look forward to seeing Jake's qualifying run on this leaderboard.
I've already got some performance enhancing.
Very nice. Yo, that's how you do it.
All right, so we've got about 45 seconds here until the end of the pod.
Okay.
TooTallToby.com. Hit us with those 45 seconds and we'll say goodbye for the day.
Please go and check out the website, TooTallToby.com. Sign up for a free account. Try out the practice models. It's like going to a gym for 3D CAD. And if you think you've got what it takes, sign up for the upcoming 2025 Spring Open Tournament. It's totally free to enter, and we would love to see you in there.
Well, that's it.
Awesome, dude.
That's it. Thank you so much for being on the pod. This has been a blast.
Thanks so much, man.
Also really enjoyed seeing your live model. I know I saw those comments in the chat, but that is going to conclude for today. So this has been the CADclass podcast. I'm Josh.
I'm Jake.
I'm Toby.
And it was a pleasure to be with you all.
Thanks, guys.
Thanks so much, guys.
Awesome.
See you next week.